Hi guys, so let's start with paper 1, March 2016. Question number 1. Which compound contains two different elements with identical oxidation states? Let's see. So you have HClO. In HClO, you have H plus, ClO minus. Let's find the oxidation state of chlorine here. So that would be X plus minus 2 is equals to minus 1, and X comes out to be plus 1. If you see, hydrogen has plus 1, chlorine is also plus 1. These are two elements with the same oxidation state. Therefore, the answer is A. Right here, magnesium is 2 plus, oxygen is 2 minus, hydrogen is plus 1, sodium is plus 1, sulfur is plus 6, oxygen is minus 2, ammonium is plus 1, this is minus 1. So the answer therefore is A, where you have H, which is plus 1, and Cl, which is also plus 1. For the element sulfur, which pair of ionization energies has the largest difference between them? So sulfur is in group 16. So since it's in group 16, it has 6 valence electrons. If it has 6 valence electrons, when you'll be removing the 7th electron, there will be a big jump. So between the 6th and the 7th ionization energy, there will be a big difference. Therefore, the answer is D, because you will be, when you remove the 7th electron, that will be from an inner shell. So as you'll be moving to another shell, that'll be closer to the nucleus, and it will require a big amount of energy, or there will be a big jump. Which ion has both more electrons than protons and more protons than neutrons? So you have protium, which is the isotope of hydrogen, deuterium, and oxygen. Now D minus, so let's see for D minus, the number of protons, electrons, and neutrons. So right here, this is, let's see, option A. D has, it is 2, 1. So this has 1 proton. It has 1 electron, but because you've gained 1, so this will be 2 electrons, and 2 minus 1, that is 1 neutron. So it has more electrons than protons, that's true. More protons than neutrons. No, the protons and neutrons are the same. So D minus A cannot be the answer. Then we have option B, H3O plus. So let's see, hydrogen, right, the protium has 1 electron each. So there will be 3 electrons of hydrogen. Oxygen has 8 electrons. And because you are losing 1 electron, so the total electrons would be 8 plus 3, which is 11 electrons, but you've lost 10 electrons, so that'll be 10. Let's count the number of protons. So oxygen has 8 protons. Protium has 1 proton each, so there'll be 3 protons. So that's 11 protons. And neutrons, for hydrogen, there's 0 neutrons, and there will be 8 neutrons, 16 minus 8 for oxygen. So the total number of protons are 11, which is more than the number of electrons. So this statement is wrong, doesn't apply. Therefore, this can't be the answer. Let's check for OH, which is the answer. So let's do that directly now. Oxygen has 8 protons, 8 electrons, 8 neutrons. Hydrogen has 1 proton, 1 electron, 0 neutrons. Total protons are 9. Total electrons are 9, but you've gained 1, so that'll be 10. And you have 8 neutrons. Do you see you have more electrons than protons? Yes, you have 10 electrons, 9 protons, and more protons than neutrons as well. Therefore, the answer is D. Question number 4. Which species contains the smallest number of electrons? The answer for that is helium plus. As you can see, helium is 4, 2. So it has 2 electrons, and you've lost 1, so that'll be 1 electron. H minus has 2 electrons. Be2 plus, beryllium has 4 electrons. So 2 plus means you have lost 2. So that's still 2 electrons. Boron has 5 electrons. You have lost 3. So that will also be 2 electrons. The answer, therefore, is D, where you have just 1 electron. Moving on to question number 5. Nitric oxide and bromine vapor react together according to the following equation. They've given you the delta H. This is exothermic. So the exothermic profile, let's see. We can eliminate the endothermic profiles. In exothermic reactions, the reactants have more energy than the product. The reaction has an activation energy of 5.4. What is the correct pathway for this diagram? Now, if you see, the reactants must have higher energy than the products. That is exothermic. So for all of these, that is absolutely correct. These are the reactants, products, reactants, products, reactants, products. We really can't eliminate any option here. Then let's see. The activation energy is given to you as plus 5.4. Now, the activation energy for an exothermic reaction is not this entire thing. The activation energy is just this. Yes. So A is wrong because they've labeled the activation energy wrong. Yes. The delta H for an exothermic reaction is this from the reactant to the product. Therefore, B is also wrong because they have labeled this entire thing as delta H, which is wrong. Delta H should have been this. So A and B are wrong. Let's see option C. That is also incorrect because the delta H has been labeled incorrectly. It is not from the product to the reactant. The arrow goes from the reactant to the product. Therefore, this is also wrong. And the answer, therefore, is D. As you can see, activation energy and delta H are correctly marked. This right here is the activation energy, and this right here, arrow from the reactant to the product, is your delta H. Which series shows molecules in order of increasing bond angle? Methane is 109.5, BF3 is 120, ammonia is 107. So there's not an increasing order, there's an increase and then a decrease. A cannot be the answer. Water has a bond angle of 104.5 or 104. You can say this is 180 and BF3 is 120. Again, there's an increase and then a decrease. This can't be the answer. Option C. 107 for ammonia, 109.5 for methane, and 180 for carbon dioxide. Do you see there's a consecutive increase? Therefore, the answer is C. Let's see why it can't be D. So there's 107 for ammonia, 109 for methane, 109.5 to be exact, and 104.5 for water. So there's again an increase and then a decrease. So this can't be the answer. Question number 7. What is the volume of steam produced when 1 gram of ice is heated to, so ice is H2O, yes. They've given you the temperature in degrees Celsius and pressure in kilopascals. They need you to find the volume of steam produced. So you can find the volume of steam produced. So let's use the formula. PV is equals to nRT. So the pressure has been given to you. The pressure is given in kilopascals. For this equation, the pressure must be in pascals. Volume must be in meters cube. Moles are moles. And your R, the value of R is 8.314. And temperature must be in Kelvin. So we need to put appropriate SI units here. Now the pressure is given in kilopascals. So we'll convert it to pascals. 1 kilopascals has 1000 pascals. So 1 kilopascals has 1000 pascals. You have 101 kilopascals. So that will be X. You can cross multiply and this will be 101 times 1000 times the volume, which is X, which we need to find. Now the moles, either you can just convert the 1 gram of ice to moles, or you can do mass upon MR as well. So 1 upon 18, 1 is the mass. MR of water or ice is 18. The value of the gas constant, which is 8.314, times temperature. This must be converted into Kelvin. The temperature is given in degrees Celsius. You convert it to Kelvin by adding 273. So this will be 323 plus 273. The volume that we will get will be in meters cube. So the volume or the value of X that we get will be in meters cube. You have to convert it to dm cube, and when you do that, the answer comes out to be 2.7. Question number 8. Solid carbon dioxide is similar to solid iodine in its structure and properties. Carbon is in group 14, silica SiO2 is in group 14 compound. Which statement about CO2 and SiO2 are correct? So they're saying that carbon dioxide is like iodine, which we know is a simple molecular structure. It is covalent, but it's simple molecular. SiO2, on the other hand, is a giant macromolecule. They're both covalent, but one is giant, one is simple. So let's see which option is correct. Both solids exist in a lattice structure. That is correct. Yes, because both solids are lattices. Both solids have simple molecular structure. That's not true. Both solids have atoms joined by single covalent bonds. That's not true. In carbon dioxide, it's not a single bond. Both solids change spontaneously to gas. That's not true. The giant macromolecular structure, which is SiO2, cannot change into gas spontaneously. The answer, therefore, is A. An article in Science magazine contains the following statement. It is lighter than a feather, stronger than steel, yet incredibly flexible, more conductive than copper. And that is a quick recall. That should be graphene. It's an allotrope of carbon. Which equation is an enthalpy change of reaction for which corresponds to the standard enthalpy change of atomization? What is atomization? Where 1 mole of gaseous atom is formed from its constituent element in their standard state under standard conditions. So 1 mole should be formed, therefore the answer cannot be C or D because you're forming 2 moles of atoms. Now, it can't be B either because you're making chlorine gaseous atom from chlorine liquid. That is not the standard state of chlorine liquid. That's not the standard state of chlorine. Chlorine naturally exists as a gas. Therefore, the answer is A. Question number 11. In an experiment, 2 moles of hydrogen and 3 moles of iodine were heated together in a sea container allowed to reach equilibrium at fixed temperature. The container had fixed volume of 1 dm cube. At equilibrium, there were these many moles of iodine present in the mixture. Calculate the value of Kc. So let's write the expression for Kc first. It would be concentration of products. So that'll be concentration of Hi raised to the power 2 because the moles will go as the power upon concentration of the reactants. So you have concentration of the products upon reactants. Let's write the equation. So you have hydrogen, iodine, and Hi. Now we need to find the moles. The initial moles are given to us. We need to find the moles at equilibrium. So the initial moles of hydrogen are given as 2 moles. Initial moles of iodine were given as 3. And initial of Hi would be 0 because initially the product is 0. Then at equilibrium, they are saying that you have 2.4 moles of iodine. So now we need to find all of this. We need to find the reacted and the equilibrium moles of the other reactants and products. So if initially iodine was 3 moles and you are left with 2.4 at equilibrium, so that means how much reacted? 3 minus 2.4, that is 0.6. The ratio of iodine to H2 is 1:1. So if this much reacted for iodine, the same amount of H2 would have reacted. Initially H2 was 2. How much reacted? 0.6. So how much are you left with? 2 minus 0.6, that will be 1.4 at equilibrium. Now, since these guys are in the ratio with Hi as 1:2, so if this is 0.6, how much would this react? This would be 1.2 because the ratio is 1:2. So if this is 0.6, Hi would be 1.2. Initially it was 0. At equilibrium, now you will have 0 plus 1.2, that will be 1.2. So you found the moles at equilibrium. Now we just need to plug them into the Kc expression because the total volume anyway is the same. So it doesn't really matter because it's 1. So if you do moles upon volume to get the concentration, the volume is anyway 1. So it doesn't really matter. You don't really need to find the concentration as such because the volume is 1 dm cube. You can directly plug in the moles. So Kc would be moles of Hi square. So that is 1.2 square upon moles of H2, that is 1.4 at equilibrium, and moles of I2, that is 2.4 at equilibrium. And you can find the value of Kc, which comes out to be 0.429. Question number 12. Consecutive elements XYZ period 3 of the periodic table, element Y has the highest first ionization energy, lowest melting point of these 3 elements. What are the identities of X, Y, and Z? So let me just draw the ionization energy trend for period 3. So this is sodium, magnesium, aluminum, then silicon, phosphorus, sulfur, chlorine, argon. So that's how it goes. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Now they're saying that element Y has the highest first ionization energy and lowest melting point of these 3 elements. So let's see. Y can either be this, this, or this, or this. So they're saying it has the highest first ionization energy of these 3. So between sodium, magnesium, and aluminum, sodium, magnesium, aluminum, does Y, which is magnesium, does it have the highest ionization energy? Yes. And they say lowest melting point. Does it have the lowest melting point? No, magnesium's melting point is higher than sodium. So does not have the lowest melting point. So this can't be Y. Therefore, A can't be the answer. Aluminum, let's check. So between magnesium, aluminum, and silicon, does aluminum have the highest ionization energy? No, it has the lowest, can't be the answer. Aluminum, silicon, phosphorus. Does silicon, can it be Y? Does it have the highest first ionization energy? No, phosphorus does. Can't be the answer. The answer therefore is D, which is So that's D. Let's see why. So you have silicon, phosphorus, sulfur. Can phosphorus be Y? Does it have the highest first ionization energy amongst these three? Yes. Does it have the lowest melting point? Yes. Why? Because Si exists as SiO2. It's a giant macromolecule, so it has a high melting point. Phosphorus is P4. It is a non-metal, so it will have weak intermolecular force, low melting point. Sulfur is S8. It has more number of electrons, therefore higher melting point. So yes, phosphorus does have the lowest melting point and the highest first ionization energy. The answer therefore is D. When dealing with spillage of metallic sodium, is important no toxic or flammable products are formed. Which material should be used is spillage of metallic sodium. So sodium with hydrochloric acid. You know acids can react with metals, so can't use that. Ethanol also reacts with sodium to make ethoxide ion. If you remember from organic chemistry, alcohol reacts with sodium metal and it becomes what? O minus Na plus. Yes, sodium ethoxide. So this will also react. Sand, which is SiO2, giant macromolecule, it will not react with sodium. Therefore, you can use that. Sodium can also react with water, so you can't use that. Chlorine gas is widely used to treat contaminated water. Which species present in water when chlorine is gas has been added is responsible for killing the bacteria? So it is ClO minus. That is the ion that you use to kill the bacteria in that is what you use to kill the bacteria. So that's OCl minus. Because when you add chlorine to water, it makes chloric 1 acid, which has this ion, which is used to kill bacteria. Which of the table is correct? Ammonia molecule, ammonium ion. Let's see, the shape of ammonia is trigonal pyramidal. This is what ammonia looks like, trigonal pyramidal. Bond angle of 107. Ammonium ion is formed by dative bonding, where ammonia reacts with H plus to make a dative bond with H plus. If you see, the shape of ammonium ion is tetrahedral. And they both have just sigma bonds. Therefore, the answer is pyramidal, tetrahedral, sigma, and sigma. There are no pi bonds. Question number 16. Hydrogen chloride, hydrogen iodide have different thermal stabilities. Let's see which one is more thermally stable. HCl has a shorter bond length, is why it's more stable. So it's more thermally stable. HI has a longer bond length, so it's a weaker covalent bond. It's a weaker covalent bond and it is therefore less stable. The difference is due to difference in the energies of some of the covalent bonds that are involved in decomposition, which row identifies more stable of the two compounds, gives the correct explanation. So which is more thermally stable? More thermally stable is HCl. So therefore B or A can be the answer. C and D are not your answers. So let's see which explanation fits. Why is HCl bond stronger? HCl bond is stronger than HI is why it is more stable. The answer therefore is B. HCl bond is stronger than HI. And why is it stronger? Because it has a shorter bond length. You should know strength of a covalent bond is directly proportional. So strength of a covalent bond is directly proportional to bond energy and inversely proportional to bond length. The shorter the bond length, the stronger the bond. And HCl has a shorter bond length. Why? Because the radius of chlorine is smaller. So the internuclear distance is less. Ammonium sulfate and ammonium nitrate are used as fertilizers. These salts have different percentages by mass of nitrogen. They have same effect as each other on the pH of neutral soil. Which row is correct? So you have ammonium sulfate and ammonium nitrate. Which one has more percentage of nitrogen by mass? So you can calculate that. And ammonium nitrate seems to have more nitrogen as opposed to ammonium sulfate by mass. You can calculate that. You can put the mass of nitrogen upon the total mass. So that's ammonium nitrate having more percentage. And they are saying the salts have, they have the same effect as each other on the pH of neutral soil. So what will they do to the pH of soil? They will decrease the pH. Yes. So the answer therefore is A. Ammonium nitrate has more percentage by mass. So that will be nitrogen, which is 14 times 2 upon the total, which is 14 plus 4 plus 14 plus 16 times 3. You can check this percentage will be much greater than the percentage of this. That would be 14 times 2 divided by 14 times 2 plus 8, which is for hydrogen, plus 32.1 plus 16 times 4 times 100. So this will be a lower percentage as opposed to this. And they have ammonium ions. So those ammonium ions will cause a decrease in the pH of soil. Ammonium is a conjugate acid. So it will decrease the pH of the soil. River water and chalky agriculture areas contain these ions. And in water treatment plants, such as water treated by adding calculated quantity of calcium hydroxide, what will be precipitated from the river water following the addition of calcium hydroxide? So when you're adding calcium hydroxide, that will give you calcium ions and hydroxide ions. So let's see, calcium chloride, that is soluble. So that will not be a precipitate. Calcium carbonate will be a precipitate because carbonates are insoluble. Nitrates are soluble, so these are soluble. And calcium chloride is also soluble. So the only thing that will precipitate is calcium carbonate because carbonates are insoluble. After black and white photographic film has been developed, unreacted silver bromide is removed by reaction with sodium thiosulfate. Now, you haven't directly done the reaction of AgBr with sodium thiosulfate, but if you remember from group 17, you must have done the reaction of AgBr with ammonia to make AgNH3 twice plus Br minus. So somewhat the same thing is happening here. You are making something similar, yeah, and releasing the AgBr as ions, dissolving the AgBr into ions, making it soluble because AgBr is insoluble. It's a cream precipitate, yes, and you're adding sodium thiosulfate, so it is just making it soluble, releasing it in the form of ions. So let's see, what is a function of the thiosulfate ions? It is to make the silver ions soluble. Do you see? Silver bromide, which is a cream precipitate, is becoming ions. So that's the whole purpose. People who take statin drugs to control the blood cholesterol may also take coenzyme Q10. Diagram shows simplified structure, one form of this coenzyme. Which row describes the structure correctly? The coenzyme. So let's see what the coenzyme is. So the coenzyme right here, if you can see, it is an aldehyde or a ketone. So let's see. As you can see, it has ketone groups right here. So it is definitely not an aldehyde. It has a carbonyl carbon with carbon on both sides. Yes. Do you see carbon on this side, carbon on this side? So it has a ketone group. Carbonyl carbon with carbon on both sides. So it's a ketone group, not an aldehyde. So A and B can't be the answer. The number of pi bonds in one molecule. So let's see the number of pi bonds that you have in one molecule. So this right here is N. This is represented as N. So let's see the number of pi bonds. In a double bond, one bond is sigma, one is pi. So if you see, you have 1, 2, 3, 4. So basically N, which is this, plus 4. So that would be D. A ketone with N plus 4 pi bonds. Question number 21. Which type of isomerism is shown here? So as you can see across the double bond, you can look for cis-trans or geometric isomerism. So let's see, can this double bond show geometric isomerism? So this carbon has one H, one CH2OH, both are different. This carbon has one CH3 and one, all of this, both are different. So this can show cis-trans. This one has H and all of this is different, and this side has one CH3, another CH3. This one can't show, but this double bond around here, you can show cis-trans. Then let's check the other molecule. Around this double bond, you have two CH3s. So again, they're similar, can't show cis-trans. Let's see this one. CH2OH, both are different. CH3 and all of this. Do you see the position of the groups? Here you had the CH3 and all of this. Here you had the CH3 and all of this. But on this side, you had a CO2H here, CH2OH here. So this is cis and trans isomerism, geometric isomerism. The positions are different. CH3H, the light ones are on opposite sides. The light ones are on the same side. This one is probably the trans isomer, and this one is the cis. So how do you figure out the cis and trans if all four groups are different? If the heavier ones are on the same side, then it is cis. If the heavier ones are on the opposite sides, then it is trans. So this right here is the heavy one. This right here is the heavy one. So the heavier ones on opposite sides, trans, heavier ones on same side, cis. So that's how you figure out cis and trans. You see the heavier ones are on the same side downwards. So this is cis, and they're on opposite sides here. So this is trans, but they are cis and trans. A section showing 2 repeat units addition polymers shown. What is the identity of the monomer that produced this polymer? So definitely must be a double bond here. Do you see the repeat unit comes right here? So this is one repeat unit and then the other one right here. So this must be C double bond C with a CH3, with a Cl, with a CH3, with a CH3. So this is what you have. So let's name this. So when you name this, the longest carbon chain is 1, 2, 3, and 4 carbons. Yes, I can draw it like this so that it's more easy to understand. So you have a CH3 on this carbon, a Cl, a double bond, a CH3, and a CH3. So the longest carbon chain or the parent chain is 4 carbons. Now, alkene is the most important functional group, should get the least number. So wherever you number from, it will either way be what? Carbon number 2. So this becomes carbon 1, 2, 3, 4. So this is what? 2. So chloro, you should always write the halogen first. So that's 3 chloro, 2 methyl, but, 2 ene. Or if you number it from this side, now you see that's not the option. So maybe they've numbered it from this side, because either way, alkene gets the least number. So 1, 2, 3, 4. Now chloro is on carbon 2, so that becomes 2 chloro. That becomes 3 methyl, but, 2 ene. And therefore the answer is B. Question number 23. But, 2 ene 1,4-diol is converted in 2 steps through an intermediate X into oxobutane dioic acid. So basically what's happening, from but, 2 ene 1,4-diol, you are making dioic acid. So basically the alcohol is becoming carboxylic acid. This alcohol is also becoming carboxylic acid. The alkene, something happens in the middle, whatever it is, and then the alkene is now making a ketone. So the alkene becomes a ketone, and the alcohols, both are primary alcohols, which are becoming carboxylic acid. And they've shown you that oxidation is occurring right here. Yes? So how does alkene become a ketone? Let's see. So let's see the step reagent for step 1. Now for step 1, if you use cold acidified KMnO4, this will become a diol. If this becomes a diol, and then to that you add hot acidified KMnO4, that will not give you this. That will not give you this. That will not give you oxobutane dioic acid, because this will become a ketone. So this will become a CO, and this will also become a CO. But you just have one ketone here. So that can't be the answer. Yes? So this can't be the answer. And X would become a diol. So they've only shown one alcohol, so that's not X. Anyway, so this is wrong. Hot acidite K2Cr2O7. When you add dichromate to this, nothing will happen to the alkene because they oxidize with KMnO4. So the primary alcohols, however, can undergo oxidation and they can become acid. But once they become acid, in step 2, alkene cannot become ketone. So even if this is X, even though they have shown B correctly, but in our step, if this is X, when you add dichromate or when you add manganate to that, this will not give you this oxobutane dioic acid, because when you add manganate to this alkene will split, the double bond will split, and you will get you won't get a ketone, you will get acid from both ends. So even though B technically is right, but according to the reaction sequence, it is incorrect. Let's see. Then you have option C, you add steam and H2SO4. When you add steam, that will result in electrophilic addition. So the steam, H will go to one of the carbons and the OH will go to another carbon. Yes, so that's what will happen. So you'll make alcohol and one of them will become alcohol. X has been shown correctly. Yes. And now you see one of the alcohols, if one of them is a secondary alcohol, so you will get one ketone. Yes, so that seems correct. X has also been drawn correctly. And then it makes sense also that when you oxidize it, this secondary alcohol will become a ketone. The primary alcohol will become acid. Primary alcohol becomes acid. So this is correct. Can't be D. Warm acidified K2Cr2O7, when you do that, the alcohol will become what? Carboxylic acid or even aldehyde. But with warm K2Cr2O7, alkene does not become alcohol. So this is wrong. Therefore, the answer is C. Question number 24. 4 students, W, X, Y, and Z, made following statements. All atoms in a molecule of T lie in the same plane. So let's see that. In T, they're saying all of them, they lie in the same plane, all the atoms. Now, in the same plane means planar structure, which is sp2 hybridized. But if you see this carbon, they have 4 sigma bonds, 1 bond, 2 bond, third and fourth is a hydrogen. 1 bond, 2 bond, third and fourth is a hydrogen. So these are sp3 hybridized. So they are not in the same plane. Therefore, this is wrong. Compound V contains only one chiral center. So let's see compound V. This right here is a chiral carbon. This is also a chiral carbon. So that is also wrong. Compound V does not have one, but it has 2 chiral centers. Do you see this carbon has a H, OH, and this group, which is the third, and this group, which is the fourth. All 4 are different. This is one chiral center. And the other chiral center is this one. It has a CH3 and H. Those are both different. This is the third group, which is different from the fourth group, which is this. So it has 2 chiral centers. So it can't be W and X. W and X are wrong. So definitely you're only left with Y and Z, because X is wrong, W is wrong, W is wrong. So X and W are wrong. Therefore, you're only left with Y and Z. Step 1 is an electrophilic addition reaction. Yes, do you see the double bond is becoming a single bond? That's addition of alkene. Step 2 is nucleophilic substitution. Do you see the halogen is becoming alcohol? That is nucleophilic substitution. That is correct. Question number 25. Structural isomerism, stereoisomerism should be considered in answering this question. J, reacted with KOH dissolved in ethanol. 3 isomeric alkenes with molecular formula C4H8 are formed. Now you're reacting the halogen with KOH in ethanol. So this is what? Elimination of halogenoalkanes. And that makes alkenes. So let's see, what is J? So you have CH3, CH2, 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 Br. Now what happens is, with elimination, the Br with the neighboring H is lost, and there is a double bond in its place. So this is the alkene that we will get. If you look at this alkene, this is what? But1-ene. So there is only one isomer. They are saying 3 isomeric alkenes are formed. You see, this can't make any other positions because this doesn't even show cis trans. So this definitely is not the answer. Let's see option B. So you have CH3, CH, Br, CH2, CH3. So now this can lose this H and this Br, and the double bond can come here. So you can make but1-ene. Then you can also lose this H and this Br, and you can make but2-ene. So this is one alkene, which is but1-ene. This is but2-ene. If you look at but2-ene, but2-ene can show cis trans. because they told you to take into account stereoisomerism as well. So it has a HCH3, both are different. HCH3, both are different. So this can show cis trans. So they won't be counted as one, they will be counted as two isomers. So this is one isomer, this is the second, this is the third. The answer therefore is B. Moving on, question number 26. Which row correctly shows primary, secondary, and tertiary alcohol? Primary is where the carbon with the OH has one neighboring carbon. So you see the carbon with the OH has one neighboring carbon directly attached to it. This is primary, that is correct. Secondary, carbon with the OH should have two neighboring carbons. So if you look here, the carbon with the OH, this is primary, this is secondary. Now, this is also correct. I mean, this is secondary. Then tertiary, this is primary, this is secondary, this is primary. So this is not tertiary, A is wrong. Carbon with the OH, one neighboring carbon, this is primary. Carbon with an OH has 1, 2, 3 neighboring carbons. This is not secondary, this is tertiary, B is wrong. C, carbon with an OH has one neighboring carbon, primary is correct. This is primary, this is also primary, this is not secondary, that's wrong. So the answer obviously is D. Do you see carbon with the OH has one neighboring carbon, primary. Carbon with the OH has two neighboring carbons, secondary. Carbon with an OH has three neighboring carbons, tertiary. That is absolutely correct. Question number 27. Fragrance of perfume is often dissolved in solvent Y, which is a molecular formula C7H12O4. It is made by reacting propane 1,2-diol with ethanoic acid in the presence of an acid catalyst. So you have propane 1,2-diol, and you react it with ethanoic acid, and you make an ester basically. Now, let's see. So you have propane 1,2-diol, and they're saying you have C7H12O4. So you react it with ethanoic acid. So let's react this with ethanoic acid. When you react it with ethanoic acid, so if you see right here, they've given you O4. That means the 4 oxygens. 4 oxygens and 7 carbons. So even if you react one acid with one side of alcohol, that would give you 1, 2, 3, and 4, and 5 carbons. So you need 2 more carbons. So that means probably there's another acid molecule reacting from this end. So now this acid loses the OH, alcohol loses the H, and this becomes water, and you have ester right here, ester linkage. The H and the OH are gone. This loses the OH, this loses the H, and this becomes water, and again this becomes your ester linkage. The H is gone. So basically we have CH3, CO2, CH2, CH bracket CH3, O, CO, CH3. Yes? So we can see which of these fit. CH3, COO, CH2, CH3, COO, CH3. So if you see here, this right here is what we have made. So they're saying, what is the structure of solvent Y? So let's see the structure of solvent Y. So solvent Y would be, let's see which one fits. That would be this one right here, D. As you can see, it's a CH3, CH3, CO, CO, single bond O, CH2, CH2, CH3, CH3, C single bond O, C double bond O, CH3, CH3. It can't be A because you have a C double bond O here after the CCH3. After the CCH3, this one, you don't have a double bond O, you have a C single bond O. So this part is wrong. Again, this part is wrong. Yes. So therefore, you can see which one fits, that is D. Which mixture could be used to produce propyl methanoate? So that means you must have used propanol. Methanoate means you must have used methanoic acid. So to make propyl methanoate, you must have used methanoic acid, that is 1 carbon acid and 3 carbon alcohol. You using 3 carbon acid can't be the answer. 1 carbon acid could be the answer. 1 carbon acid could be the answer. This is 4 carbon acid, can't be the answer. So A and D are absolutely wrong. Let's see B. In B, you are using 1, 2, 3, 4 carbon alcohol. You need a 3 carbon alcohol. So this is wrong. The answer therefore is C. 1, 2, 3 carbon alcohol, that is propanol. 1 carbon acid, that is methanoic acid. Therefore, the answer is C. Which statement about polychloroethane is correct? So this is a polymer. The polymer can be cracked to produce chlorinated alkenes. So polymer is alkane. Yes, because the monomer is alkene, you make a polymer which is an alkane. So can you crack that? Yes, because alkanes can be cracked. Polymer is harmless combustion products. That's not true because it can give off carbon dioxide. And if it is incomplete combustion, it can also give you carbon monoxide, which will be harmful. It is readily biodegradable when buried. It is not. Polychloroethane cannot be. It is non-biodegradable. The repeat unit of polymer is MR of 97. So let's see. Chloroethane. So that should be this. Let's see, is this 97? So it will be 12 times 2 plus 3 plus 35.5. That does not add up to a 97. So 12 times 2 plus 3 plus 35.5, that's 62.5. The answer therefore is A. Which row of table is correct? Increasing number of carbon atoms, ethyl methanoate, so that means it's a 2 carbon alcohol, 1 carbon acid. Then you have methyl propanoate, so that's a total of 3 carbons. Methyl propanoate, that means methanol, 1 carbon alcohol, 3 carbon acid, so that's 4 carbons. Pentyl, which is 5 carbon, pentanoate, which is 5 carbon, so that's a total of 10. Propyl, which is 3 carbon, 4 carbon, so that's a total of 7. So this can't be the answer because you don't have increasing number of carbons. You go from 3 to 4 to 10 to 7. So there's a decrease from 10 to 7. Ethyl methanoate, so that's 2 carbon, 1 carbon, total 3. Methyl propanoate, so meth is 1 carbon, prop is 3 carbon, so that's total 4. Propyl butanoate, so that's 3 carbon and 4 carbon, so that's 7. Pentyl pentanoate, so that's 5 carbon, total 10. This seems like a increase. Yes. The answer therefore is B. Do you see from 3 carbon to 4 carbon to 7 to 10? Moving on to section B, which molecules have an overall dipole moment? Let's see. Carbon monoxide, so that's carbon with just 1 oxygen. So this is partial negative, partial positive, dipole towards oxygen. Yes, it does have an overall dipole. Phosphine, phosphine is a polar molecule as well because it has lone pairs of electron right here. So due to the lone pair, it is also polar and there will be a dipole towards phosphorus. Carbon dioxide, it has no net dipole, even though the bonds are polar, but there will be a dipole this way, it's linear molecule, dipoles cancel out. This is non-polar. Therefore, the answer is B. Diagram illustrates the enthalpy change a set of reactions. So they've given you this. Which statements are correct? Enthalpy change for transformation U to R is 42 kilojoules per mole. So they're saying U to R. So let's see. We need to find from U to R. So you need to find U to R, and they're saying that this is 42 plus 42. So let's say U to R is what you need to find. You know, this is plus 92. So the backward would be what? Minus 92. This is minus 134. So this way would be plus 134. Can we take U to be the starting point? Do you see there's a tail and a tail here? So can we consider this to be the start? And there is a head and a head here. So can we consider this to be the end? And this is your intermediate. So you can go from start to end directly, which is X, which is equal to start to intermediate. Start to intermediate will be this arrow, that is minus 92 plus intermediate to end, which is this arrow, which will be plus 134. And X comes out to be plus 42. That is correct. Enthalpy change for transformation. Now we know X. We know what X is. We know X is plus 42. Transformation from T to S, they are saying is endothermic. So let's see T to S now. So T to S, they are saying this is endothermic. So let's see. Can I say T is the starting point because you have a tail here and a tail here. So this is the start. This is the end. Yes. So this becomes your intermediate. So you can go from start to intermediate, which is start to end directly, which is minus 75, which is equal to start to intermediate, which is X, plus intermediate to end, which is 92. So this will be minus 75 minus 92 is equals to X. And the value comes out to be negative. This is not endothermic, it is exothermic. So if 1 is right, 2 is wrong, the answer will always be D, because there's no option here which says 1 and 3 are correct. So 3 will also be wrong. We can also check it though. So let's check 3. Enthalpy change, R to T. What is R to T? This. Now we already knew U to R. We know U to R is plus 42. So they're saying R to T is minus 33. So let's find this. Now if this is R to T, this is plus 42. I can do it this way. This would be minus 42. Can I call this the start? 2 tails. Can I call this the start? And can I call this the end? Yes. And can I call this the intermediate? So you can go from start to end directly, which is now minus 42, which is equal to start to intermediate, which is X, plus intermediate to end, which is minus 75. So that will be minus 42 plus 75. That will be equals to X, and X comes out to be plus 33, not minus 33. Therefore, this is also wrong. The answer is D. Moving on to question 33, which statement about reversible reactions are correct? An increase in concentration of a reactant always increases the concentration of the product. So if you increase the concentration of the reactant, the system will try to decrease it. Yes. So for example, if you have A plus B giving C plus D. So if you increase this, system will try to decrease it. Equilibrium will go forward. You will get more product. That is true. Increase in temperature always increase in temperature always increases the rate at which equilibrium is established. So if you increase the temperature, the rate will increase. That is true, because if you increase the temperature, the rate will obviously increase because more successful collisions. So there will be increased rate because more successful collisions if you increase the temperature. An increase in temperature always increases the concentration of the product at equilibrium. That does not matter. I mean, that is not for sure because it depends on the delta H. If the delta H is positive, if you increase the temperature, system will try to decrease it and then it will move forward and then it will increase the concentration of the products. But if it is negative, then it will not. So therefore the answer is B, because option 3 is not always true. It is only true if delta H is endothermic for the forward reaction. Question number 34. Chemist puts sample of dilute aqueous hydrochloric acid in beaker 1, adds sample of zinc, measures the rate of production of hydrogen. So you know zinc metal plus HCl will give salt, zinc chloride plus hydrogen gas. This will be 2. Now, the rate of reaction, beaker 2. Okay, then she puts a different sample of hydrochloric acid into beaker 2. She adds a different sample, measures the rate of production of hydrogen gas. Rate of reaction in beaker 2 is greater. So they're saying rate in beaker 2 is greater. What factors could help to explain this observation? The rate reaction in beaker 1 has a higher activation energy than reaction in beaker 2. That is not true because both the reactions are the same. So if the reactions are the same, their activation energy will be the same because in both you are using the same thing, zinc and HCl. So their activation energies can't be different. They'll be the same. So 1 is wrong. The answer therefore is C. In beaker 1, large pieces are used than in beaker 2. Yes, that could be the reason why rate in beaker 2 is more, because larger pieces means that you have less surface area. Less surface area means less rate. The acid in beaker 1 is at lower concentration. You know, concentration higher means greater rate. Concentration lower means less rate. But since the reactants were the same, so activation energy will be the same. So option 1 is wrong. Rice-going parts of the world, farmer use combination of paddy fields such as fish farm, rice paddy fields are flooded, blah, blah, blah. Which problem could result for farmers applying excess nitrogen-based fertilizers to their paddy fields? If you use nitrogen fertilizers, they've told you they are very soluble. So what will be the problem? Yes, because those nitrogen fertilizers can go into the nearby rivers and lakes. It could result in eutrophication. Yes, eutrophication, they will go in the nearby rivers and lakes. They will cause algae to bloom because of more nitrogen content. The fish will die. So yes, this is a problem. Decreased levels of oxygen in water. Yes, that is also a problem because when algae will bloom, the sunlight will not reach the deeper layers of water. There will be decreased photosynthesis. There will be less oxygen. Increased growth of algae. Yes, because increased nitrogen content that goes in the nearby rivers and lakes. Therefore, the answer is A. 36. Sample containing 0.4 mole of calcium nitrate was decomposed. So you have calcium nitrate decomposing into calcium oxide, 2 moles of nitrogen dioxide, half a mole of O2. What are the products of this reaction? So you have 0.4 moles of calcium nitrate. So you can convert, so you have the moles of this. So you have 0.4 moles of calcium oxide. Yes, because the ratio is 1:1. 0.4 moles of nitrogen. You don't get nitrogen. You get nitrogen dioxide. 0.4 moles of oxygen. No, the ratio is 1:half. So it's not going to be 0.4, it'll be half of that, not 0.4. The ratio is 1:half. Therefore, the answer is D. Which reagents, when used in excess, can be used to make sodium lactate from lactic acid? So in lactic acid, how can you make sodium lactate? Reacting it with sodium? Yes, because sodium will react with acid and make what? Salt. Yes. All right. So which reagents, when used in excess, can be used to make sodium lactate from lactic acid? So let's see. CH3, CHOH. Now, not only will the sodium react with the acid, it can react with the acid, yes, but it can also react with alcohol. So this is not going to be OH. This will become O minus Na plus as well. So yes, even though sodium will react with the acid, but it also reacts with the alcohol. So it will give you CH3, CH, O minus, Na plus, CO2 minus Na plus. Not this. So yes, it could react with acid, but it will also react with the alcohol. So you will not get sodium lactate. You will get this with sodium. Therefore, one is wrong. The answer, therefore, is C. Because one is wrong, the answer will be 2 and 3. And that'll be sodium hydrogen carbonate. So yes, that carbonate will only react with acid. So carbonate only reacts with acid, not with alcohol. Therefore, it will give you sodium lactate. NaOH also will only react with acid, not with alcohol. So only with acid, not with alcohol. Therefore, they will give you sodium lactate. 38, chlorine atoms in the upper atmosphere cause breakdown of ozone. Which statement is correct when referring to the chlorine atoms? Chlorine atoms act as catalyst. Do you see chlorine is regenerated? Do you see it was being used here, making ClO minus, and then it's regenerated just like a catalyst. So it is regenerated and then it further goes and breaks the ozone. So yes, it is acting as a catalyst. Chlorine atoms are free radicals? Yes, because they have an unpaired electron. What is free radical? Species with an unpaired electron. So chlorine has 7 outer electrons, 1, 2, 3, 4, 5, 6, and the 7th is unpaired. So they are, yes, radicals. Chlorine atoms are formed by heterolytic fission. Heterolytic is non-homolytic fission, which is where you form ions, but these are radicals. So radicals are formed by homolytic fission, not heterolytic fission. So this is wrong. Radicals are formed by homolytic fission, by equal splitting, where 1 electron goes to each atom. Question number 39. Unknown organic compound Z reacts with sodium to give a combustible gas as one product. Z does not give a yellow precipitate with alkaline aqueous iodine. What is the possible identity of Z? So it gives you one gas as a product. Ethanoic acid. Will ethanoic acid react with sodium? Yes, it reacts with sodium to give sodium ethanoate, salt, and hydrogen gas. Yes, so this is correct. Pentanethreol. This will also react with sodium to give sodium. So it will also give you sodium salt. Yes. So you will have pentanol. So this is your pentanol. So this will become your salt and hydrogen gas. This also reacts. Propanol will also react, and it will give you salt and hydrogen gas. Answer therefore is A, because all three react with sodium. Compound X has the molecular formula C3H6O3. Heating under reflux with K2Cr2 forms this. Reacting with NaBH4 forms this. What's the possible structure for X? So let's see. When you heat it with dichromate, it gives you a ketone, acid, acid. So that means it must have a primary alcohol here, secondary alcohol here. Yes. So let's see. A primary alcohol, it's an acid, so stays acid. So if you heat it with dichromate, do you see this can't give you a ketone because this is just CH2. I mean, this primary alcohol will give you acid, okay. But how are you getting the ketone? If there's no alcohol here, so there's no ketone. How can you get a ketone? So since there's no alcohol here, 1 is not your answer. And this acid stays as it is, fine. But how do you get the ketone then? So 1 is wrong, because you must get a ketone from this. This gives you acid. This acid stays the same. But how did we get the ketone then? So 1 is wrong. And if 1 is wrong, the answer is always C. Let's see. Primary alcohol giving you acid. There is a secondary alcohol giving you ketone on oxidation. Aldehyde giving you acid on oxidation. This is correct. Primary alcohol giving you acid. This is a ketone as it is, stays as it is. Primary alcohol giving you acid on oxidation. And that is also correct. The answer therefore is C.